Hey, so this lesson is on, what is this? Oh yeah, the unit circle and circular functions. The circular functions are actually just the trig functions. And we're going to learn right now why they're called the circular functions on this little video. So here you go.
This is the unit circle. The unit circle is a circle that has a radius of 1 and has its center on the origin. It's called the unit circle because the radius is 1 unit, so the unit circle. Doesn't seem like a big deal, but we can do a lot of things with this unit circle. Now, since we know the radius is 1, let's take a look at the arc length formula. We used this last time. We had S equals R theta. S equals R theta was a formula, but we know that R is 1 at this point. So when we're talking about the unit circle, we can just say that S equals theta. And now we're going to be referred to as angle is the same thing as a distance. So our input and output, our domain and range is all real numbers. I'm going to apply this idea that R equals 1 to something else, the trig function. So looking at sine, we used to say that sine theta equals y over r, and that's still true, but for the unit circle we know that theta equals s and r is 1. So we can change that to sine s equals y, where the input s and the output y, the domain and the range, are both real numbers. Neither one of them is an angle. Same thing with cosine. We said cosine theta equals x over r, but since theta equals s and r equals 1, we have cosine s equals x. Similar for tangent. Tangent theta equals y over x. We can't change the y over the x, but we can change the theta to s. So tangent s equals y over x. So here's what that's going to look like on a circle. So we have this circle here. We have 2 points of a circle. We have 1, 0, and we have some other point, x, y, that's also in the circle. And we know that the arc that connects those two things is length s, and the angle that connects those 2 points through the middle, the central angle, is angle theta. And we know from what we just found is that s equals theta. And we know that the sine of s equals y, and that's cosine of s is x. And that's all we need to know. Now I'm going to show you what that looks like for every angle that we had on the chart that we made a couple days ago. So here's a circle, and I'm a unit circle, and here are all the measures that we had on the table. I'm going to go ahead and add something to that and put those measures also in radians. So the red is the angle in radians. And the black I'm going to put up here. That's the x and y value for every single one of those points for that angle. So you would connect the center to the 30 degrees. You'd have root 3 over 2 and 1/2. Okay, the sine is the y. The cosine is the x. If you have this picture in your notes, you don't need anything else. Table-wise, you know the values for every sine, every cosine, and if you know how to do it, every tangent, cotangent, cosecant, and secant.
Okay, so that did a okay job in telling you what the circular functions are and where they come from and what the values are, but not what actually you're going to be doing. What you're going to be doing is solving problems like this one, like sine 7 pi over 4. It's actually pretty easy. So give you a second, go back to your circle and look at 7 pi over 4. Looking at it. Oh yes. 7 pi over 4. Oh, there it is. It's in the fourth quadrant. You'll find it, and you notice that the coordinates are root 2 over 2 and negative root 2 over 2. Well, remember the sine, which is what you're looking for, of anything is the y value of the coordinate on the unit circle. So to find an exact value of the sine of 7 pi over 4, the answer is negative root 2 over 2. That's similar to what we were doing on the chart. It's just now we're using the circle instead of the chart. I want you to use the circle because I want you to get a chance to use both the circle and the chart to get an idea of what you were doing. To which one you like better? I'm sorry. Another example. Tangent of 3 pi over 2. Look at it. Okay, the tangent of 3 pi over 2, similar. You look it up in the table. I'm looking at 3 pi over 2 over the circle. 3 pi over 2. Oh, that's down there. That's 270 degrees. Okay, and it's 0, negative 1. And remember, tangent is y over x, in which case that's negative 1 over 0, which is undefined. See? Simple as that. I looked it up in the chart. I made my thing. Here's where it gets a little trickier. We have to find the cosine of negative 5 pi over 3 because it's negative. I didn't have negative numbers on the chart. I had positive numbers. So you have to figure out what angle is coterminal with 5 pi over 3. Now, because there were 360 degrees in a circle, when we did coterminal angles with degrees, you added 360. In radians, there are 2 pi radians in a circle, so you add 2 pi. But how you add 2 pi to 5 pi over 3? Well, you have to get the common denominator. So 2 pi is like 2 pi over 1. Right? Well, you have to add those. You have to have a common denominator. The common denominator is 3. So if we multiply them by 3, that gives you 6 pi over 3. And when you have fractions, you just add the tops. So negative 5 plus 6 is 1. So it's 1 pi over 3. So really, if we're looking for the cosine of negative 5 pi over 3, that's going to be the same as the cosine of 1 pi over 3, which is the x value at pi over 3. So we look at the circle. Pi over 3 is at 60 degrees. The x value is 1/2. So the cosine of negative 5 pi over 3 is 1/2. And that's what we're going to be doing when we find exact values for the trig functions. Next, I'm going to talk about approximated values. So I don't want to be too blunt about it, but in order to do approximated values, all you got to do is put it in the calculator. So here's one example. The cosine of 1.85. Now, I'll have to ask, is that in radians and degrees? I really don't have to ask that, because is there a degree sign? No, there's not. That means it's radians. So the first thing you do is get out a little trusty dusty calculator. Okay, turn it on, and what did I just say? Are we doing radians? Are we doing degrees? We're doing radians. So the first thing you do is hit mode. Make sure your calculator is in radian mode. Whenever you do this, anything in the calculator for the rest of the year, the first step you're going to always do, first thing you always do is make sure you're in the right mode. You might need radian, you might need degree. Depends on the problem. But we're in radian mode now. So I put in cosine 1.85. I hit enter, and I get an answer. And that's what I put, negative 2.2756. Alright, how's that? Done. Now let's show you a little bit of a harder one. That's super easy. The harder one is, here's one. The cotangent of 1.3209. Why is that harder? I know why it's harder, because we don't have a cotangent button on the calculator. I got sine, cosine, and tangent. I don't have cotangent. So we got to change something. Cotangent's 1 over tangent. So we do 1 over tangent 1.3209. Gives me 0.2552. Beep. Done. So that's it. That's it for approximations. That's all you got to do. All you got to do is plug it in the calculator and go with it. Super easy. That's what everybody's going to want to do. Everybody should do really well on the homework. And that's it. See you in class next time.